So what we did in a recent paper, that is still work in progress, so if you have any questions or ideas or thoughts, please let me know. I used the research publications, the academic research publications, as an indication of research in a country. And I know in energy this is very, it's not necessarily representative, but I used it as a proxy. So energy-related research. And I found that top 10 countries in energy-related research production. Spain, Australia, France, Canada, United States, Germany, UK, Japan, Netherlands, and Italy. And I looked at the change in R&D in these countries from 1990 to 2011. Okay? So you see Spain, something happened in Spain, energy R&D. It increased by more than 800% from 1990 to 2011. I put an asterisk next to that. Always when we find outliers in our data, we put asterisks next to them. It might be a data issue. But you see all the rest, Australia 200, France more or less 100%. So it's the latest decade, 1990, 2011. All the rest very, very, very small change. To Italy and Netherlands having a negative change from 1990 to 2011. With Netherlands, I still need to investigate. Italy, I assume it's some sense of economic crisis there. In the green, you're going to see the change in energy research in these countries. And energy research, as I said, measured in academic papers in energy-related topics. So the highest one, the highest change in energy research came in Spain, where it was the highest change in energy R&D. Can that be perceived as the more money I spend, the more research I get? Question mark there. Why question mark? Because on the right-hand side of the graph, you see Japan, Netherlands, UK, Italy, Germany having a high percentage increase in energy research, while the change in energy R&D was not significant. So the question is now, is GDP what drives energy research, like most papers show? Is R&D driving research? So the more money we throw, the more research we get out. The question, the two next questions that, well, the two next steps we took to see what is the answer to that question was firstly to look at different types of applications, of energy applications. So what you see here is, again, International Energy Agency categories. It's categories of R&D. Okay, so group 1, energy efficiency, group 2, fossil fuels, group 3, renewable energies, group 4, nuclear, group 5, hydrogen and fuel cells, group 6, other power and storage technologies, while group 7, it has cross-cutting technologies. So it's energy R&D spent in these types of categories. And looked at the average share of different energy R&D to total energy R&D in these different countries between 1985 and 2012. We see some groups, like nuclear, receives quite a big share of energy R&D in all these countries. We see some other types of groups, like renewable energies, receive quite a lot of energy R&D in specific countries, but not the rest. And we see countries like France having primarily nuclear promoting energy R&D, while US we have a much more equal distribution to different technologies. So the one point that I'm trying to make here is it's not only energy R&D in total, we all understand how multidimensional the energy sector is, but also where we spend this energy R&D. the results of this paper showed that the social benefit, the positive social benefit was yielded by investment in energy R&D in Group 1, energy efficiency, and Group 3 for all the countries. All the others had mixed results, except Group 2 that had a negative, so it had a social cost, and yeah, it was fossil fuel, sorry. It was only Group 2 that had negative social impact. So it depends where we spend the energy R&D. Let me save you the academics slide that talks about definitions and just what other people have said, and basically saying what I said in the previous slides. What I want to show you here it was something interesting that we saw in our analysis, again with the top research producers. So the blue line shows the average number of energy-related papers. We see a certain increase through the years, but a serious, more steep increase from the 2000s onwards. And the average energy R&D decreasing and then increasing. So we look at two different periods. The period before 2000 with the energy R&D decreasing and the research publications increasing, and the second part having the energy-related papers increasing in a steeper rate, while the average energy R&D also start increasing with some spikes. So we proceeded with the composition analysis just to look at the factors that affect these two periods. So what we looked at how the GDP affects these periods. The second one that we looked is the R&D intensity effect and the R&D return effect. So how many papers per 1 unit of R&D spent, which is the productivity of R&D. So investors want to hear that. When I invest in R&D, I want to know what I'm going to get back. So what we saw that was something very interesting. We saw a mirror result. So before 2000, the biggest positive contributor and the only positive contributor to energy research was the GDP. So the more it's the economy, the highest the energy research producing. The other two factors were negative. They were declining and they were negative. After 2000, where we saw that steep increase in energy research, we saw exactly the opposite. The GDP doesn't play a role anymore, or it plays a small negative role. Why is that? Because from 2008, it started end of 2007, 2008, we've experienced dismal economic conditions globally. So GDP didn't play a role there. What played a role was the R&D intensity. So how much energy R&D I have in my total R&D intensity. How much energy R&D to total R&D. And the R&D return. So how productive, how quality was that investing in research and development. So the second point I'm trying to make is not just spend money. It's not just R&D. It's not just throw money in the market or in the sector, just give money to the researchers, but make sure there is something coming out from the production, from the research production. So points to take with. Don't want to keep you too much from lunch. Accessibility and affordability of energy needs new and innovative solutions. Traditional way of thinking is costly and not working since we experience what we experience now. Digitalization is already improving the safety, productivity, accessibility and sustainability of energy systems, but digitalization or new technologies is also raising new security and privacy risks. It is also changing markets, businesses and employment. New business models are emerging, while some century-old models may be on their way out. Improvement of old and development of new technologies is the way forward, which is self-explanatory. Investment in R&D might have more socioeconomic, energy and environmental benefits than actually investing in energy production. And that is not me that I'm saying that, but the literature. We should, however, be careful because non-appropriate allocation of energy R&D funds into various technologies or ignoring the R&D productivity and research quality might create more problems than it would solve. So if in our efforts to increase energy R&D, we decrease R&D expenditures from other sectors, we're not solving any problems, we're creating more problems actually. Food for thought. Is research and dialogue the new R&D? So do we need more forums like this? Well, as the president of South African Association for Energy Economics, I would say yes. Yes, we need more. We need more of this. We need to start thinking what other people are doing. We tend to be secluded in our labs and in front of our laptops and do what we're supposed to do and maybe collaborate here and there. But especially in the energy sector, you can't collaborate just here and there. You need to collaborate widely. Economists cannot work without engineers, without geologists, without all the other lawyers. I remember a couple of years ago, I was doing a project, I'm not going to say for which client, but I had in front of me electricity generation plant. A design of that, trying to understand what gets in, what gets out. And my husband back then said to me, I thought you studied economics. What is that? But in energy economics, there's not what is that. You need to understand even a little bit of everything. And if you don't understand, you need to find out who understands. So if something comes my way and I need to look at waste, I'm not going to try and learn it myself. I'm going to contact UNISA and try and find how it works. There's no point of me trying to learn everything myself. So we need dialogues, not only for the sake of the dialogue and for the sake of the networking, but also understanding how multidisciplinary and cross-disciplinary is the energy sector. So having said that, I invite you all to the launch, but most of you will also get the invitation. And so that I'm not really finishing in that, please let me know. Thank you very much, and I appreciate any comments or questions.